Hello and welcome to this new video. Today I will do an explained run-through to the Road Las Vegas 2024 case. I think it's round 2, the case Sommelier. I will put a link where you can buy this case in the video description, and I will also link, I think there are a few solution videos out there from other guys like Tim and so on. I will also link those videos in the video description here. So here's the case. There isn't so much about the instructions. You can skip them. You only need to read those instructions there, but it's worthwhile to take a look at those tables here. So I will first unfreeze this because I don't like those free stuff. I will not put this into tables because I don't need them for my solution way. But yeah, as you can see, these are two-dimensional tables. So you don't have only here a category and then their value. You have a category on the y-axis and also a category on the x-axis. And then you have at the crossing, you have the different values. A so-called two-dimensional table. Yeah, I have a video on my channel where I do a run through to all the methods you can solve with two-dimensional tables with, or do an XLOOKUP in two-dimensional tables. I will link it in the video description, and hopefully if I found the button, I will also put it at the corner somewhere up there. Yeah, but never mind. I've also loaded my lambdas in. I will do two things. For the first example, I will do an XLOOKUP without the lambdas, and otherwise I will use the lambdas for this two-dimensional XLOOKUP because it doesn't make sense to show you all the ways every time. And I recommend to take a look at the linked video I've done on two-dimensional XLOOKUPs if you want to give them a try. So now we do the non-lambda method. So first I look up here after the attribute body in here, and I will return as a return array all of this. You now see there's a spill because XLOOKUP can spill, and I will now look here after the Y name in this row here, and now it will search for the because I've first with the first XLOOKUP I returned this here, so like the body, and with the next XLOOKUP I will search for the row this value is in. So now make everything stable. Here I want to have a bracket there, and I can now track everything down and it's solved. There are other ways to do two-dimensional XLOOKUP. Yeah, for example, I have a lambda for that. 2D underscore 2D. So my return array, for example, with my lambda this, search array for row is this, search array for column is this, criteria for row is this, criteria for column is this, and this will also hand you the value out. And if I fix everything, it will give, took some seconds. It will also give you the same results. So here, this was quite easy. I don't think I should explain the instructions there. Here for the next, you should find out the absolute value difference. So if it's negative, it should become positive between those attributes. So both for the customer and the wine paired with the attribute. So this is only two XLOOKUPs wrapped in an absolute formula and together subtracted from each other. So L underscore 2D. So first, let's take the customers first. And you see, every time I fix the referencing, you should and can do this while putting the formula in. Now I lost it, and you see it takes me a little bit longer if I don't do it immediately. Wrong direction. Column fixed. So search criteria here is my wine and also my attribute. Close all the brackets. You see here I've wrapped this in an ABS formula. Give me the absolute value. I can track this down, and the level is solved. We are at 100 points currently. Not the best, but also not the worst. So now for level 3, we should look for the wine with the smallest absolute value difference. So here the wines aren't given, but the attribute is given and the customer is given. So for this, I will first do an two-dimensional lookup for our customer, for this attribute from our customer. Then search area for column, for row is this. Oh, sorry, I forgot to fix everything. See, it takes me a little bit longer, and time is key normally for esports cases. So now I have the value for those customer, and then let's wrap here an ABS around. I will take every wine in, so only look for the attribute in here and return everything. Sorry, this didn't work. So in here, sometimes it's a little bit laggy. So now it should work. And why isn't there an NA? Oh, I'm so dumb. Sorry. I need to look for the attribute and not for the wine itself. So, and now I get a list of all the wines and the absolute value difference regarding the attribute, and I can now do an XLOOKUP here for the smallest value, for in this case 0. This is my lookup array, and my return array only needs to be the same size, need not to be on the same table or so on. Match mode should be exact match or next larger item, because I think the possibilities that there is a value difference with 1 isn't so large. And now I now get the value, and I don't need to think about the alphabetical sorting because this list is already sorted alphabetically. And I can now track this down, and the whole level is solved. So now we need to sum the absolute value difference for the attributes between customer and wine pairing. This is easy. Only look up for the guy there, for the customer there, inside here, and return then the whole row with values minus next lookup for the wine in the wine table, and return also the whole row. And you can now wrap there around an ABS function and wrap there around a sum function. Yeah. And you get the value. This was quite easy. And you can now track this formula down. And we've solved another level. Now, level 5 is a little bit more tricky. You need to find the best wine, and the best wine is determined by the smallest absolute value difference between all attributes and the customer. And also here, if there's a tie, use the alphabetically best wine. So I will first do an XLOOKUP for the customer in the customer array, in the customer table, and return the whole values there. And then I will do basically the same as before. I think with the level, was it this level? Yeah, I don't know. I think it was this level, but without the attribute type this time. ABS, and this time minus XLOOKUP, no, not XLOOKUP, minus the whole array, because we don't have values there. So, and I get now, oh, sorry, I need to copy it a little bit further that you can see it. I get now a list for the absolute value difference for every wine and every customer. So this only for show. And I now use the by row function to sum this up by row. Lambda A, sum A. And I now do another XLOOKUP for the 0, so small number. My lookup array is my sum there, and my return array is my wine list. Match mode as before 1, and I now get a value there. Copy the formula in here. You see it's solved, and it's also solved for the other wines there. So this will be a little bit more complicated. So we should calculate the total score for the given customer and wine pairing, and the total score is determined based on the attributes, so the absolute value difference of attributes. So XLOOKUP for the customer in the customer tab, return the whole row minus XLOOKUP for the wine in the wine table, and also return the whole row. And you now get here values. Now let's wrap this into an ABS function. And we now need to look up for those values here. And therefore we use an XLOOKUP function. This is our XLOOKUP value. We look up here at the minimum, fix this, and our return array is our score. And if we now make the match mode to exact match our next smaller item, we don't need to think about the maximum value here, because if it's like if it's 12, it will jump to the 5 because it's next smaller item. And for example, if it's 91, it would jump to 50 because it's the next smaller item. So also use the optional arguments with XLOOKUPs. Yeah, sorry, forgot the match mode. -1 is the match mode. Yeah. And now wrap this into a sum function. Copy this in here. And you can now track this down, and the level is solved. So next one is a little bit more tricky. We should, oh, there are 8 levels. So we should determine the best wine, and the wine is calculated based on the lowest total score, and therefore we use the formula from above. So we don't need this. XLOOKUP is done for this guy here. We don't need the sum function currently. And we don't need this XLOOKUP here. And we now subtract this from all the wines. Fix everything. And we now get a list for the absolute value difference for every customer and every wine. Let's do an XLOOKUP here where we look for this in the table there. -1 is our match mode. And we now get here value table with the scores. Now we need our by row function. Lambda A, sum of A. We now get a list here, and if we now do an XLOOKUP for 0, so a small value, our lookup array is our calculated thing here, and our return array is the name of the wine. Match mode is exact match on next larger item. We now get here the first value, and it's already alphabetically sorted because we use XLOOKUP here. Okay, there's something wrong. Oh, yeah, okay, sorry. Never thought about this. There could also be negative values there. So I will search for -150, do an XLOOKUP for this. XLOOKUP -150, why -150? Because with 5 attributes and 5 times -10, oh no, so only 50. 5 times -10 is -50. Look up here, return the vines from there. Sorry, never thought about negative values there. Exact match on next larger item is okay. Now there's a different result, and the result is right. Can now track this down. Everything solved. We are currently at 800 points, and we're going to the last level. So here we should look for the wine with the lowest adjusted price, and the lowest adjusted price is the 5 times the total score plus the price. Yeah, and therefore we can use our function here, so our bio function from before. Oh, sorry, erase the equal sign. But XLOOKUP here is our guy here. Now we have a list for the score. Now we add the price with a simple sum, and we can now do again an XLOOKUP -50. I don't know if this is necessary, but I will do it that way. Return match mode is also 1, so exact match on next next larger item. We have a result for this. It's right, and we have a few errors there. So this shouldn't be good. So in a real life scenario, I wouldn't see those errors. So but it's often the case with Trend Primitivo. Don't know why. So here we have our texture is searched for the values. -1 is the search mode. We add the wine price. This should be right. Should be right. So bio sum So decide attributes for main field. Lowest adjusted price. Is the sum of the wine's price plus 5 times the score. Oh, I'm an idiot. I forgot to take the scores 5 times. Yeah, times 5. There are also errors. Why? This shouldn't be the case. Average primitivo. Let's deconstruct this. Don't need the X lookup here. Oh, sorry. Okay. It's possible that they are less than 55. So here our minimum is minus 55. That's a problem when you use this XLOOKUP function here and you don't know what the lowest value is there or the highest value. So what I will probably do then is use an let function. Let's name this whatever you want, and then do an XLOOKUP for the minimum of M inside M and return then the array based on this. This is a little bit more safer. Exact match. Here we could use exact match there because we know what the minimum value is. And you now see the safe route will lead to the result. Now 1000 points. How many customers are not listed in levels 2 to 5? So what I will do is either copy those customers in or use my bonus setup lambda for this. Level 2 to 5 are those customers here. You could also do this manually, but I don't want to. So then I will show unique and count this with rows or with count. You can use whatever you prefer. 56, and I know that there are 100 customers in. So 100 minus 56 is 44. So 44 customers aren't in the list. That's right. So across both customers and wine, there's one attribute number which appears the most. Okay, let's also do this here. So first I will do an haystack to call for those values and also for those values. Oh, sorry, not an haystack, an vstack. Yeah. Sorry, didn't close the brackets properly. So I think the prices I excluded. So we now have a list here of our 1000 values, 2 times 5 times 10 attributes. And I can now do unique of this and count if those values, if there are those values. And I will now sort this array after the second column, and the attribute also in the other order. So I have the highest number there, and the highest number is 92, and it will appear 17 times. So 92 is the number, it's searched after the number. you should read properly. Sometimes they ask after the count, sometimes they ask after the number. So here, you should pay attention to that. So if you were to apply the level 5 rules to determine the best wine for all customers, which one is the best? There's one wine which is the best for most customers. So level 5 rules are here. Let's do this that way that I will go into the customer tab, copy the formula in, and now my XLOOKUP is here. This will lead to an error. I don't know why. So I now use the map function to map every customer name in. Lambda A, this is A, and I now get the best pairing for every customer. Now I need also the unique function, then COUNTIF, or COUNTIFS you could also use, and we can now also sort this. Sort this after the second column, scanning, and the Riesling here is the best for most customers. And that's right. So you could also use here, where is it? Here, for example, Lambda you have pre-written, for example, most of Lambda, and this will be a little bit faster than doing all this stuff. So now only 2 bonus questions to do. So there's a riddle, so you should offset the first letter from 127 to again number 130 by the places of the game number, and also everything lowercase letters. Okay, but I don't think it made a difference in the real battle. So this, let's copy this into a separate sheet. So here are our values. Now I need the first character of all of this. It's a D. Now I use the code function here. I subtract 64 is the code for A, I think. For large A. 65. Oh, sorry, I subtract 65 plus 1, so 64, because D is the fourth letter. And then I add here the game number. I do a mod for this -1. Divisor is 26 plus 1. And now we use the char function to make everything into chars. But we need to add 64 again. And we can now lower concat. And there's our answer. Yeah, and it's right. So first this will give me the left letter, so the first letter, and then I use the code function to make everything of this values into Unicode. Then I subtract the large A because I have 26 letters and all the Unicode before doesn't matter. Then I add those numbers here, -1 because with -1 you can do an mod where you have also the number as an output, so you don't have output 0 if it's divisible by 26. You have 26 as an output. Then I divide by 26 with the mod function and add 1 plus 64 to came back to the Unicode for the letters, and then with char I make everything into letters and then add everything together. So, and the last one, using level 5 approach, which is what is the most expensive adjusted price across all possible customer wine pairings. So how do I face this challenge? Okay, I use this function. Go to the customer tab. This will get a little bit messy, sorry for that. And I now output, instead of an XLOOKUP, I use max from M to output me the maximum value, and I do this for every customer I map therein. Lambda A, this is my customer. Will not work. Okay, the question is why. I see. That's the problem when you copy them hardcode in. But I can fix this. Now this should work. Yeah. We have the maximum pairing for every customer. We can now use the max function to determine the overall maximum. And it's 997. And I think 997 is the such number. And we are a little bit over 30 minutes, but I've explained a lot. And you see 1250 points. So you see it's quite an easy case. You could score here full points if you know how to do an two-dimensional XLOOKUP at first, and otherwise later it will become quite easily if you know how to handle two-dimensional arrays. Yeah, thank you for your attention. I hope to see you with the next case. If you have any questions, feel free to ask them in the comment section. Bye.